Welcome to Kanerika's podcast, The Digital Shift. Think for a moment about the traditional way we plan massive projects.
Right, like building a major piece of infrastructure.
Exactly. Imagine you are constructing a towering high-rise building right in the middle of a city. You start with a fixed blueprint.
You absolutely have to.
You do. Every single steel beam, every electrical conduit, and every pane of glass is meticulously mapped out on paper before a single shovel ever hits the dirt.
That makes perfect sense for physical construction.
Right, because the physical world absolutely demands that kind of rigid predictability. If you mess up the foundation, you cannot just pivot halfway through the build.
No, you certainly cannot.
But, modern digital initiatives operate under an entirely different set of rules. Building enterprise software today is not like constructing a static building.
It is not even close.
It is much more like navigating a living, unpredictable ecosystem where the terrain shifts constantly underneath your feet.
Well, that is a fundamental distinction. And it is exactly where so many organizations go wrong.
I would love to explore why that happens.
In a physical construction project, the laws of physics do not change halfway through the build. Gravity is a constant,
Right. Gravity is highly predictable.
Exactly. But in digital ecosystems, the business requirements, the technological capabilities, and the market demands are in a state of constant aggressive flux.
That sounds like a recipe for disaster if you're using a rigid plan.
It is. Attempting to force a rigid, static blueprint onto a completely fluid environment is precisely why so many massive enterprise projects eventually collapse under their own weight.
And unpacking that tension is exactly our mission for this episode. We are going to explore why rigid, upfront plans inevitably fail in complex digital projects.
It is a critical issue to understand.
It really is. And we're going to look at how embracing structured uncertainty completely transforms project outcomes.
That shift in mindset is where the real value lies.
Ultimately, we're going to examine how this adaptive mindset drives massive, measurable impact in enterprise digital transformation.
I'm very excited to dive into this.
Me too. The primary mechanism we are focusing on today is known as adaptive software development, and specifically its core engine, which is the Speculate-Collaborate-Learn cycle.
To really grasp the power of that cycle, it helps to understand the historical shift. We need to look at how software development evolved to handle the exact unpredictability you just described.
Let us take a step back then. Where did this all start?
Well, if you look back, for a very long time, enterprise software followed a strictly sequential, highly rigid process.
You were referring to the waterfall model, right?
Yes, the classic waterfall approach. If you have been in the industry long enough, you know exactly what this looks like.
Oh, absolutely. First, you gather requirements for months.
Right, and then you write a massive, hundreds of pages long specification document.
Then you hand that document over a metaphorical wall to the design team.
Exactly. Who then toss it to the engineers to build, and finally it goes to testing right before it ships.
It sounds so logical on paper.
It does, and honestly, that sequential model actually functioned reasonably well back when requirements were genuinely stable.
But things did not stay stable for long.
No, they did not. By the 1990s, the enterprise environment was accelerating dramatically.
How bad was the disconnect?
It was severe. A software specification written in January was often completely obsolete by June, simply because the market had already moved on.
Oh, wow. So the plan was essentially dead on arrival half the time.
Pretty much. The waterfall model had zero efficient mechanisms to absorb those rapid changes. Every single adjustment meant halting production entirely to renegotiate the master plan with stakeholders.
So if the traditional sequential method was actively failing by the 90s, who actually cracked the code on a better way to operate?
That brings us to Jim Highsmith and Sam Bayer.
What were they working on at the time?
They were working extensively with rapid application development, or RAD, during that era.
Okay, so they were already trying to speed things up.
Yes, and they observed firsthand that complex, fluid problems are not solved by trying to predict the future better.
That is a profound realization.
It really is. They realize that these problems are solved by creating the right conditions for a team to learn quickly and adapt to reality as it happens.
And they turned that into a formal system.
They did. They formalized those insights into a very specific methodology called adaptive software development, which they published in the year 2000.
Okay, I have to push back on this a little bit.
Please do.
We are talking about something published in the year 2000. Since Agile is so ubiquitous today, isn't adaptive software development just a historical footnote at this point?
Well, it is easy to assume that.
Yeah.
But the distinction is absolutely crucial for any team trying to actually deliver value.
How so?
Agile is merely an umbrella term. It represents a broad family of methodologies that happen to share 4 philosophical values.
Right. It is more of a philosophy than an instruction manual.
Exactly. Adaptive software development, on the other hand, is a specific, highly actionable methodology within that family.
So it came first, essentially.
It did. In fact, just a year after publishing it, Jim Highsmith traveled to a ski lodge in Snowbird, Utah.
That is the famous meeting, right?
Yes. He sat in a room with 16 other developers. Together, they co-authored the 2001 Agile Manifesto.
So Highsmith literally brought the DNA of adaptive software development directly into the broader Agile movement.
He absolutely did. The 4 core values of Agile, prioritizing individuals and interactions, working software, customer collaboration, and responding to change, are all distinctly present in Highsmith and Bayer's methodology.
That is fascinating. So it is not a footnote, it is the intellectual ancestor.
Precisely. But the problem today is that people confuse the Agile philosophy with operational frameworks.
Can you give an example of that?
Take a popular framework like Scrum, for example. Scrum relies heavily on defined roles and rigid ceremonies.
Right. Things like fixed-length sprints, daily stand-ups, and structured sprint planning.
Yes, Scrum gives you a very specific operational manual for how to run your week.
But it lacks the underlying philosophy.
Scrum is entirely about process and cadence. Adaptive software development is less about dictating your meeting schedules and entirely focused on the underlying discipline of managing uncertainty.
So you can do one without the other.
Exactly. Here is the trap. You can run all your Scrum ceremonies flawlessly, and you can check every box on the daily stand-up.
But it might not actually matter.
Right? If you do not have the adaptive discipline of treating every cycle as a genuine learning exercise, you are just going through the motions. You are doing mini waterfalls.
That makes perfect sense.
Adaptive software development is the intellectual engine that actually forces a team to confront reality.
Let us look under the hood of that engine then. Instead of standard planning and execution phases, this methodology actively functions on a continuous 3-phase cycle.
Yes, the cycle is speculate, collaborate, and learn.
And that cycle repeats continuously for the entire lifespan of the project.
It has to in order to be effective.
We should break down the first phase, which is speculate. This is brilliant because it fundamentally replaces the illusion of perfect upfront planning.
It really is a genius naming convention. The creators deliberately avoided using the word plan because a plan implies certainty.
Right, when you say you have a plan, stakeholders expect a guarantee.
Exactly. Speculation explicitly acknowledges that you only know enough right now to begin.
And that your understanding will inevitably change as you encounter real-world friction.
That is the core of it. During the speculate phase, the team defines a clear business mission.
But I think we need to clarify what a mission actually looks like in this context. It is definitely not a sprawling list of technical tasks.
No, it is decidedly not a feature list.
Yeah.
A mission establishes the overarching business boundaries, the budget, the timeline, and the constraints.
So it is much higher level.
It is. More importantly, it plans in user-facing capabilities rather than technical milestones.
Think about the difference there. Building a customer analytics dashboard is just a task.
Right. But helping sales representatives identify high-value accounts faster, well, that is a mission.
This distinction keeps the entire team deeply focused on outcomes that provide real utility.
Yes, rather than just ticking boxes on a technical checklist. And because it is explicitly a speculation, when requirements change, which they always do, it is not treated as a disaster.
It is treated as vital information. It is not scope creep, it is reality making itself known to the team.
Treating change as valuable information rather than an annoying deviation is a massive psychological shift for enterprise teams.
I can imagine. So once that speculation is set, you move immediately into the execution phase, which is collaborate.
Yes, and this phase demands genuinely cross-functional teams.
We are talking about engineers, business leaders, and governance officials working together constantly, right?
Absolutely. It forbids the traditional practice of handing a specification document down a chain of command.
Cross-functional collaboration is non-negotiable here.
It is. If you are migrating a massive enterprise data platform, your engineers simply cannot solve the architectural constraints without the business leaders in the room defining what success actually looks like.
That makes total sense.
Yeah.
And neither of them can move forward without governance ensuring compliance?
Right. The collaborate phase forces all these interactions early and often, when design decisions are still cheap and very easy to change.
Because if you wait until the end to collaborate, fixing an architectural flaw becomes astronomically expensive.
Which naturally leads to the final, and I would argue the most critical phase of the engine.
The learn phase.
Yes, learn. This is not just a quick retrospective meeting bolted onto the end of a long project where everyone just pats themselves on the back.
Right. It is a rigorous, continuous process.
It has to be rigorous, and it must encompass 4 very distinct areas of learning. First, you have customer learning.
This asks the blunt question of whether the product actually solves the business need based on real usage.
Exactly. Not based on what they said they wanted, but what they actually use. Second is technical learning.
That is asking if the architecture holds up under the pressure of real data in a live environment, correct?
Yes. Then you have process learning. This is where you evaluate if the team is operating efficiently or if the workflow itself is causing unnecessary friction.
Like asking if we are bogged down in approvals.
Exactly. And finally, business learning. Has the broader market, the budget, or the corporate strategy shifted entirely since we started the cycle a few weeks ago?
If you miss even one of those 4 areas of learning, your next speculate phase is going to be built on a foundation of completely unverified assumptions.
That is exactly the danger.
This sounds a lot like planning an expedition into uncharted territory. You know exactly which mountain peak you want to reach.
Right. That is your mission.
But you have to adjust your exact path daily based on the weather and the terrain you actually encounter on the ground.
That is the perfect way to visualize it.
If you just stare blindly at a map you drew at base camp and ignore the blizzard right in front of you, you are not going to make it.
You certainly will not. You cannot pre-plan a rigid route through a blizzard you have not encountered yet. You have to move forward, gather data about the actual conditions, and adapt your trajectory on the fly.
Now, we need to shift from the theoretical framework of this cycle to the concrete, measurable impact this methodology has on enterprise business outcomes.
Because a great theory does not mean much if it does not move the needle.
Exactly. We at Kanerika utilize this exact adaptive learning drill delivery model.
We do, and the enterprise impact we see is profound.
Yes. When we at Kanerika engage in custom software development or complex data platform modernization, we absolutely refuse to rely on long, static, upfront specifications.
Instead, we run these short, highly collaborative cycles.
The focus is entirely on creating the tightest possible feedback loop between what we build and what the business actually requires to operate efficiently.
A perfect example of this impact is our work streamlining project management through API integration.
By utilizing this adaptive approach, constantly checking our speculation against real user needs, we achieved a staggering 42% productivity gain for a client's project teams.
That is a massive improvement. And similarly, our work elevating project management with real-time data analytics delivered an 80% faster response time.
It is crucial for you listening to note that these massive gains came directly from shortening those feedback loops, not from writing bigger, more comprehensive specifications up front.
Those metrics are the ultimate validation of the cycle. When you shorten the distance between shipping a capability and validating its success with real users, you completely eliminate the massive waste of build and features nobody actually wants or needs.
You optimize entirely for value delivery rather than just blind task completion.
Right. That 42% productivity gain happens because the team is not drowning in irrelevant tools. They have exactly what they need, adapted to how they actually work.
So to get these incredible results, we are essentially asking enterprises to trade the false comfort of a predictable timeline for the guarantee of actual, measurable business utility.
That is exactly the fundamental trade-off. And it is a trade-off that enterprise leadership must be willing to embrace for high uncertainty initiatives.
It makes sense, but it is a big leap for some companies.
It is. A methodology that expects and actively absorbs change will inevitably produce a slightly less rigid delivery date than one that artificially locks down the scope on day one.
But as anyone in enterprise tech knows, the timeline of a locked scope project is usually an illusion anyway.
It is a comforting lie. By trading that false comfort, you ensure that whatever you deliver at the end of the process is highly relevant, technically sound, and fully aligned with the current market reality.
However, we have to acknowledge that while the impact is massive, the methodology requires incredibly rigorous discipline.
It is not a magic wand you wave over a broken team.
No, it is not. There are serious pitfalls and implementation realities that can derail the entire process if an organization is not careful.
The most fatal pitfall, without a doubt, is when business stakeholders disengage during the cycle.
That happens quite a lot.
It does. Adaptive software development only functions if the business side of the enterprise shows up for the collaborate and learn phases every single time.
If they set the mission and then step back to wait for a finished product 3 months later, the engineering team loses that essential feedback loop.
And without that loop, the entire process quietly drifts back into a state of isolated guessing.
There's also a very real coordination overhead to consider, which cannot be ignored.
Running frequent collaboration sessions and forcing continuous learning across departments takes time away from heads-down coding.
Teams have to find a sustainable rhythm to avoid meeting fatigue. Otherwise, the collaboration becomes a burden rather than an enabler.
And as we touched on regarding the timeline trade-off, the inherent unpredictability of exact budgets and timelines can be a nightmare for traditional procurement departments.
They're very used to fixed price, fixed scope contracts.
Exactly. To implement this correctly and avoid those pitfalls, organizations must follow strict implementation steps.
Let us explore those implementation steps, because getting this right is where the magic happens.
Step 1 is defining a concise mission.
As we discussed earlier, this should be a short, powerful paragraph detailing the business outcome.
Why is this so hard for companies to get right?
Usually because they try to cram a massive feature list into the document and disguise it as a mission. If it takes a whole page, you are already doing it wrong.
That is very true. Step 2 is building an adaptive release plan.
You must be explicitly clear about what the team expects to learn in the upcoming cycle, not just what code they plan to ship.
You are planning for knowledge acquisition. Step 3 is enforcing that cross-functional collaboration we mentioned.
You need the real decision makers in the room, people who can say yes or no on the spot.
Yes, not just junior representatives taking notes to pass up the chain of command.
Step 4 requires running strict, time-boxed cycles. 2 to 4 weeks is the standard.
You build, you test, and you collect feedback strictly within that rigid time boundary.
It forces a sense of urgency and prevents perfectionism from stalling the project.
And finally, step 5 is that you must measure actual outcomes. User adoption and business impact are the true metrics here, not just the sheer volume of output.
Think about it. A team that ships complex features at lightning speed but produces tools no one actually uses has fundamentally failed to learn anything.
That is a brilliant point. We also need to be perfectly clear about when this methodology is a terrible idea.
It is definitely not for everything.
No. Adaptive software development is a poor fit for fixed scope, compliance-driven work where the requirements are genuinely static.
Like updating a regulatory reporting system where a government agency has handed you a static, non-negotiable specification document.
Exactly. Do not try to run an adaptive cycle there. Just use a sequential process, follow the blueprint, and build exactly what the regulation requires.
There is no learning to be done about what the government wants because they already told you.
That makes perfect sense. You have to match the tool to the environment.
Now, connecting this concept of structured uncertainty to the current enterprise landscape, we have to talk about the most unpredictable frontier today.
You are talking about artificial intelligence.
Yes, artificial intelligence.
This is exactly where adaptive software development is experiencing a massive resurgence in relevance.
Developing AI applications makes traditional upfront planning nearly impossible.
It does. You cannot perfectly predict a language model's performance on your specific data.
You cannot guarantee your data quality ahead of time without testing it either.
And you certainly cannot forecast how human users are going to interact with an open-ended generative AI interface.
The numbers back up that unpredictability with terrifying clarity.
They really do.
Gartner estimates that 60% of AI projects will be abandoned through 2026 due to a lack of AI-ready data.
That statistic is a classic painful symptom of teams skipping the learn phase entirely.
They assume their data is clean, they build massive, expensive models on completely untested assumptions, and then they abandon the project when reality hits them in production.
Exactly. They make a single, highly confident model selection decision way too early in the process.
Completely bypassing the structured speculation and collaboration that AI inherently requires.
But what is truly fascinating here is that while AI introduces all this massive uncertainty into the enterprise, AI is simultaneously becoming the solution to managing it.
We are seeing this directly with tools like our Jarvis AI Scrum Master.
Yes, Jarvis actively automates the heavy manual overhead of the Agile process.
Things like the daily stand-ups, the task tracking, the meeting notes, and all that administrative friction.
By utilizing AI to handle that massive administrative burden, the human teams are finally freed up.
They can focus purely on high-level judgment, strategic alignment, and extracting deep insights during that critical learn phase.
It dramatically accelerates the cycle. When you automate the mechanical parts of project management, teams can actually afford to run more iterations.
And as we know from the core principles of the methodology, running multiple fast passes through speculate, collaborate, and learn will always beat making one long, highly confident guess.
It is an incredible paradox when you think about it.
AI represents the absolute greatest source of unpredictability in modern digital development. Yet AI-assisted tooling is the exact mechanism giving us the speed and bandwidth to manage that very uncertainty.
It is a brilliant paradox. We are essentially using machine intelligence to optimize the human ability to adapt.
And that is what makes it is about moving away from a futile attempt at perfect prediction and moving toward a highly disciplined system of continuous adaptation.
Because the environment is always going to change, the technology will inevitably evolve.
The market will constantly demand new solutions.
The only sustainable competitive advantage an enterprise truly has is its internal capacity to process new information, learn from it, and adjust its trajectory faster than the competition.
And as we at Kanerika continue to guide major enterprises through highly complex data platform migrations and cutting-edge generative AI applications, the defining factor of success is always exactly that.
It is always about how fast a team can learn and adapt to the reality directly in front of them.
The teams that win are the ones that embrace the shift.
It proves that the principles formalized decades ago by Highsmith and Bayer are vastly more relevant today than they ever were before.
Which leaves us with a compelling thought for you to consider as you look at your own projects.
It is a big question.
If the most successful software and digital systems thrive on continuous learning and rapid adaptation, rather than rigid upfront planning, what if we structured our entire organizations, our corporate hierarchies, and our very business models to operate exactly the same way?
That is something to think about.
Thank you for joining us for this conversation. We appreciate you taking the time to explore the digital shift with us.